Generally, PCB images will be like this. Like in PCB designs, what PCB designer will do is he will make a like circuit diagram, circuit schematic diagram. Like from this circuit schematic diagram, he'll convert the schematic circuit diagram to PCB. So initially, like it will be like circuit diagram, and logic behind the circuit is also very important. So each and every component, like how it works, everything is important. For that, mainly we'll get client input from client input like BOM and schematic bill of material. So in bill of material, we'll check the manufacturer part number. So in manufacturer part number, we'll check the component manufacturer part number. We'll enter the manufacturer part number in the BOM, and BOM manufacturer part number. We'll copy that manufacturer part number and we'll paste in the DZ key or Snapad or Mother Electronics. So we'll copy and paste there, and we'll download the datasheet from it. So in the datasheet, we can create footprints. Before that, we need to create the schematic design. Before that, we need to, if there is a symbols already, that is okay. Suppose if there are no symbols, then we need to create the symbols. We need to create the symbols, and suppose if it is a 2-pin symbol, we need to add 2 pins for it. Here, pins are used to connect from one component to other component. And so after creating those symbols are many like resistor, capacitor, inductor, diodes, transistors, um, microcontrollers, etc. So these are the symbols we need to create that in schematic editor, schematic design. Like in ORCAD, we need to create the schematic in ORCAD capture. So after that, 1 minute.
You don't
So
have any
this is a
PPT? Yeah, okay, fine. Continue.
okay ORCAD capture. So here we can create like files. Like suppose if we can create a project, we can create a new project and we can enter name here. So and we should save that in a browser. Like suppose if you want to save in C or E folder, then we need to select and we need to click OK. Okay. Then before that, we need to create the schematic symbol. Sorry, schematic design. Before that, we need to create the schematic design. File, new, and a library. So this is how we create the new library. And in library, this is the library. And library, if we want to create the symbol, then we need to take add viewport, and suppose it is a resistor. We can create those resistors. And this resistors are like manual means manual creating. We can create the symbol like this. So we can switch off the grid to get a cross symbol like this, and we can draw the symbol. So we can draw the symbol like this, and suppose for rough I'm using it. We should create the symbols very neatly. So after that, we need to give the pin numbers. We need to give the pin numbers and place pin. Here it is there, and we should enter the pin number 1 and 1 and short. So we can connect here, and we can connect another pin here. So there are 2 pins. The pins are used to connect from one component to the component. So this is a resistor. So if we want to take like automatic resistor from tool also, we can take a resistor automatically. Like in PSpice components, passive components will be there. And here we cannot take. We can take certain schematic design. Place of PSpice components, passive components, resistor. We can take from the tools directly. So in this way only we'll create the symbols. If if the symbols is there, we can there's no need. But if we need to create symbols, then we can create symbols in the library. So after creating those symbols, we need to give pins for it, in order to connect from one component to other component. So after creating those symbols, so not only this resistor, capacitor, inductor, and LEDs, we need to create the symbols for MOSFETs, transistors, BJTs also. So after and ICs and microcontrollers like quad flat packages, anything like that. So we need to create the symbols and we need to connect those symbols in from one component to other component. Then how the schematic. Then we can see the schematic design of a circuit diagram. So after creating those circuit diagram, we need to assign the footprints. So footprints will take it from the manufacturer part number given in the BOM. Suppose we'll take manufacturer part number, we'll copy the manufacturer part number and paste in the busy key. So here in busy key, we can select the components. Suppose if we take this BOM, this is the manufacturer part number. We can copy this. We can copy this manufacturer part number and we can paste in the busy key. We can paste in the busy key. There we can get the data sheet. So in this data sheet, uh, we need to check the uh, recommended lamp pattern. Recommended lamp pattern, suppose for an aluminum capacitor. So this is a through hole component. This is a through hole component. Generally, the footprints there are many. There are three types, like assembly footprint, through hole footprint, and combination of assembly and through hole footprint. In assembly footprint, 1 minute. Assembly footprints looks like this, like these are the pads, and this is the assembly outline, and these are the pads. So, uh, coming to the point, before we have taken the part number, manufacturer part number in the busy key. So after taking the manufacturer part number from the busy key, so we need to create a pad stack for it. So here we'll take an assembly footprint. Here I'm taking 0402 package. So in 0402 package, here we use this is the surface mount package, means assembly components, surface mount packages, devices. So we can take like this as example 0402 package. Generally, there are packages for a footprints, like for resistor, capacitor, inductor, LEDs. We have 0402, 0603, 0805, 1206 packages. So for a resistor, we'll take footprint like recommended lamp pattern, the data sheet. So here, this is the outline. or we can leave here. Here we can take the past step. Like there will be some rules like IPC. According to the IPC 7351, we are creating the footprint. On the past step will be like this. So initially we need to create the past step. So in the past step, so here we'll take the pad as a past step. So in this, we need to enter file new, and we need to enter like past step name. Like if it is for a rectangular past step, we can take like 80 by 50, 80 by 50, and we can take like it is an since it is an SMD footprint. We can take like single. We can take some begin layer. So here we can take rectangle, and we can enter 80 means 0.8. We can take sorry 0.8. Sorry, we should take that in millimeter because we need to create the footprint in millimeter. Now we can enter here 0.8. So this is for a begin layer. This is for a begin layer, and we can enter the values for begin layer, and this is a regular pad, and this is a thermal relief and anti pad. So we can there is no need to use a thermal pad and anti pad in the assembly footprint. We can use 13 through footprint and default and end layer and default end layer all are same, and okay for a solder must stop generally like solder must stop. So this is the solder mask layer. So for a regular pad, we need to add. This is the regular pad. Like Sorry, this is the regular path. Sorry, this is the mounting host. And 1 minute. So here we consider this green layer as the regular pad, and this red layer is the solder mask layer. Sorry, uh, red color is the solder mask, and this green is the regular pad. So here we need to enter. So for a regular pad, we need to add 0.15 mm to get the solder mask top. 0.8 plus 0.15 is 0.95. And here we can take 0.65. So similarly, copy and paste. Um, okay. And for paste mask layer, it is similar to the regular pad only. So here, paste mask, it is used as a combination of like on the top of the regular pad, there will be a solder mask layer, and between the PCB design and the component, we can use solder paste. On the top of the stencil, we use the solder paste, and solder paste acts as a paste between the component and the this PCB design. So the regular pad is paste mask layer is similar to the regular pad. So this is how we create the pad stack. File, save as. So after creating those pad stack, I need to add this in PCB editor, like file, new, and sorry, resistor. So we can take here a package symbol, and we can click file, save as. We can take this in the primary. Okay. And we can set up the paths, folder path, like user preference. We need to go to the user preference, and paths will be like library path. In library path, we can save that path path, select that folder. Okay. And we can click OK. And we can take PSM path. PSM path is nothing but footprint path. And we can take pad step. Okay. Okay. After saving this, we need to add those pins. we need to add the pins here. Here we can find the options. In this we can add the folder like what we have created the patch tag. So here we can find or 80 by 50 that we have created before in the patch tag. And we need to set the grid settings also. Like we need to go to design parameters and you need to click all the things like bus racks, thermal pads and everything. And we need to set the green grade to 0.1. 0.1. And, 0.1. 0.1. We should do that in millimeters. We should generally we should create the potential millimeters. So then we need to add the pins, and here we got the pin, and we need to place it, and we should select the origin. Um, 1 minute. And so we should place the origin. Suppose we can place the origin here, and like we can place the pads here, like pins here. So there are two pads. Suppose if we take distance between the two pads is 1 millimeter, 1 mm. So in that case, we need to enter the values. Like we need to enter the two pads. We need to enter the two pads, and we need to enter the 1.0, 1.0 mm between the two. Here y-axis there is nothing, so we can use a 0 value, and here also offset like 0 spacing between the two pads, and we can rotate it. So we can take this pad in 90 degrees, and we can uh, so we can enter a command here like x space sorry, 0 space 0. So here we have added that pins here, and this origin should be in the center. So in order to get that origin to be center, we need to change the origin. So x space 0 space 0, and we need to change the origin location, change drawing origin, and here x space 0.5. 0.5 is like when the spacing between two pads is 1 mm. So we need to half that 1 by 2, 0.5. Now the origin is at the center. Then we can make the like uh, assembly outline, and we should know the pin numbers also. Like here, there is an option like find we can off all, and only text we can take on. So we can rotate it. We can change it. So after that, we can add outline, like add a line options. So we should take here package geometry and assembly top, and the thickness of the assembly top will be like 0.1016 4 mils, and we can add the assembly outline. X space 0 space 0, and here we can take like 90 degree X space and wait a minute. Okay, we can measure from here to here to see the distance between the first pad and the second pad. And here is 1, and we can take like outline like 2. According to the recommended land pattern only we should take. We can choose package geometry and assembly top, and the thickness is 4 mils, 0.1016 in mm, and X space 0 space 0, and here we can enter like X space 2 space 1, and X space 0 space 0, and here we have found the assembly outline. So we can change that. If it is not moving, then we should on all the things, and we should see only lines, and we can move X space 0 space 0. We can take here body center instead of system order. X space 0 space 0. Okay. So after drawing the assembly outline, we can add the text to add a text reference element, and we can add like R star. We can adjust this text. We can adjust the text to the center, and later we need to add the line and package geometry and silk screen top. Silk screen top we can give another color, like, and we should give another um, trees like we should give another measurement also. We can give 6 mils, 1 2 5 4, 1 5 to 12, 1 5 to 4, 1 5. Thickness of the silk screen layer. We can give like 1 5 6. X space 0 space 0. Here we can take like X space 2 mils, and we can take 1.5, 1.5, because silk screen outline should not touch the pads. X space 0 0 space 0. Done. And we can move this lines X space 0 space 0, and done. Sorry. Add line x space 0 space 0 and x space we can take 2.5. So we should add 0.5 mm to the assembly outline more. So here we have taken like 2 and we can take here as 2.5, 2.5 and here we have taken like 0.5 and 1. Here we can take 1.5, 1.5 and we can take x space 0 space 0 and this is it done. So after that we should place this lines x space 0 space 0 and done. And we can add text for this silk screen outline, reference signature and silk screen top. Here we can give the silk screen reference signature, reference signature for silk screen. So here how is we create this silk screen outline and reference signature for silk screen outline. Then we can add DFA bound top. Sorry, edit jet copy shape and we can take here like package geometry and DFA bound top. And DFA bound top we can enter values like expand. We can take expand 0, contract 0 and we can use a DFA bound up. DFA bound up is used to protect from being short circuited. Suppose if two components are placed side by side, then there might be chances of being short circuited. So in order to avoid it, we are giving DFA bound up. So and next place bound up, jet copy shape, package geometry, and place bound up. So we need to give expand here 0.5. So here generally place bound up is determine the height of the component. Height of the component. So after that, we need to check the properties like properties. So we can enter here the package maximum height. Suppose the package maximum height, we should check that in footprint. Recommended land pattern in the land pattern 1.0. Then we should apply and okay. Then this is okay. Then we can use also the step path also. Like we can also use the step path also. Like setup step path will be so in the 16.6 version, there is no step path, but in it will be in 22 version and 24 version. In 22 version and 24 version, step path will be there. It is used to determine the 3D dimension of the footprint. So this is how we create the footprint. So after that, we'll add that footprint. We'll add the footprint in the schematic design. So we have saved entirely the footprint. So after saving those footprint, we'll go to the folder. We'll go to the folder and we can check here. this in this priming, we have got the pad. This is the pad file, and this is the PSM file. This is the footprint, and we can copy paste. We can copy here, and in schematic design, in schematic design, uh, we can paste the footprint here. We can paste the footprint here, like here it is. We should paste the footprint here. So after that, we can paste like so here. This is the wire. If we plus W part, we can get the wire. And for example, I'm connecting this wire to place power. For power, I'm connecting VCC here. And I'm connecting this second pin to ground wire and wire and ground. So now, suppose if we consider this is a small circuit, then I will like I'll check DRC. I'll take this and place create netlist. Design rule check. In tools, we have the design rule check option. We can check this design rule check. So here the design rule options: electrical rules, physical rules, and ERC matrix. In design rule, I'm checking. Okay. I'm selecting the folder. So here this is one. Sorry. So after that, I need to like import, create the netlist. So I'm selecting this design file. This is .dsns design file and tools create netlist. So after creating this netlist, we can take here Allegro, Z and training. In training, we can take this and create or update PCB design board. Ignore fixed property, allow H removal, and we can check the create the netlist here. Netlist is successfully generated. Then okay. Next we can create the board like new board. Next, suppose we'll create a, board like some training board or anything board and okay, add a line. Here in options we can take board geometry outline and line width. You can take like 0.1016. Okay, it's the space 0, 0 space 0.